Okay, we're going to look at J7 next, and this is blocks and spring. So in this problem, what we have is a mass sliding. There's no friction here in this problem, and this is sliding with velocity u1 going to the right. This is mass 1, and there's a spring here attached to mass 2, and this configuration is moving with velocity u2 moving to the right, and u1's greater than u2, so it's going to catch up to it, and there's a spring constant here, k. So what's going to happen is this mass is going to start pressing on the spring. It'll slow down while this one speeds up, and then with maximum compression at that moment, they're moving together. So if we were to look at an after situation, we would have the masses, some kind of compression here, and they're moving together at speed v. So here is m1 and m2. So this is before the collision, and this is after. And we're giving values. We're given that u1 is 15 meters per second. We're given u2 is 5 meters per second. We're given that m1, this mass 1, is 3 kilograms. And we're given that mass 2 is 15 kilograms. And we're given the spring constant K in here. This K is 1220 newtons per meter. And in the problem, they actually had point zeros in places, so that we're going to shoot for here, we're going to shoot for 2 significant figures. All right, so they had like 5.0 and 3.0, so you could go for 2 significant figures. This is actually 3 significant figures at any point. Okay, so we go here with conservation of momentum and conservation of energy. Well, let's do the energy one first this time. So 1/2 m1 u1 squared plus 1/2 m2 u2 squared is equal to 1/2, they're moving together now, so it's m1 plus m2 v squared, but now there's potential energy because the spring is compressed. So the 1/2 kx squared, and we didn't give the question here. What the question is in this problem is to find v and find the compression x. So you're asked to find 2 things. So in other words, what is the compression, the maximum compression at that and at that moment, what is the velocity when they're moving together at that instant? Then the spring's going to expand, and then the mass 1 will continue to slow down with the force pushing to the left, and m2 will still want to increase its speed, because as the spring expands, it'll be pushing the mass 2 to the right, mass 1 to the left. So if we add here our conservation of momentum, we have m1 u1 plus m2 u2, that's the momentum before, and then the momentum after. Since they move together, we can combine the masses and have v. So we have 2 equations with 2 unknowns, and we have everything given except v and x, these are the unknowns, and we can solve for v and x with two equations. So how might we approach this? Well, at this point, my preference is to just put in numbers and get this v right off the bat, right here, because see, this v is going to be equal to m1u1 plus m2u2 over the sum. And putting these numbers in, m1 is 3 kilograms, so there's 3. u1 is 15 meters per second, 15. m2 is 15 kilograms. And u2 is 5 meters per second up there. So we have this, and then we're going to add m1 is 3 kilograms plus m2, which is the 15 kilograms. And just look at the units here. I have kilograms in all places, so that's going to cancel. And then I have the u's put in meters per second, so I'm good. This is going to be fine. And if we look at this, we find that the velocity is 3 times 15 is 45, 15 times 5 is 75 over 18. And with the calculator working that out, you get 6.667 meters per second. I like to keep extra figures here and round off at the very end. That's my preference. Round off at the end. So then, once we have that, we can put this in way up in here and be finished. Now, those 1/2, I want to get rid of all those. So here, I'm going to multiply through by 2. So the energy equation is m1u1 squared plus m2u2 squared is equal to m1 plus m2 v squared plus k x squared. So this is going to go in here. m1 is 3. And this is going to be for the u1 squared. u1 is 15, so that's 15 squared. m2 is 15 kilograms. u2 is the 5 squared. So this is going to equal, now you have to add these together, that's 3 kilograms for m1 plus m2, 15. And for the v squared, we're going to have the 6.667, and that gets squared. And this is going to have, at the last term, is 1220 x squared. So I can find for x squared easily. This is very, very straightforward to do, and with the calculator, we work this out. And when it gets worked out, and the text, shows you the steps, so you can check your numbers at each step. I'll just go ahead and jump to the answer here. X squared is 250 over 1220, and that means x is, take the square root, 0.45 meters. And now we go to two significant figures, and we could write that as 45 centimeters if you like. That's x. And v, the two significant figures, 6.7 meters per second. So it's a nice problem that reviews a lot of important concepts. That takes care of it.